Every accident investigation tells the same story, told in reverse. Investigators work backwards through a chain of events, searching for the exact moment when something was missed, overlooked, or assumed to be fine. And more often than you might expect, that chain doesn't begin in the air. It begins on the ground. Before the engines ever start. Before the rotors begin to turn. This is episode 1 of Normal Procedures for the AgustaWestland AW109SP, an English learning podcast for aviation professionals. Today, we cover everything that happens before you fly, the operating philosophy that underpins every procedure in this aircraft, the flight planning discipline that turns a mission idea into a calculated and safe departure, and the pre-flight inspection, the methodical, deliberate walk around your helicopter that confirms it is exactly as airworthy as it needs to be. By the end of this episode, you will understand not just what the AW109SP pre-flight requires, but why it is designed the way it is, and what you are actually looking for at each step. Let's begin. The Normal Procedures section of the AW109SP covers the helicopter's entire operational life from start to finish, from the planning stage, through actual flight conditions, all the way to securing the aircraft after landing. Something worth understanding before we go any further, these procedures are written for normal and standard conditions. That might seem obvious, but the implication is important. Procedures give you a standardized framework. They are not a substitute for judgment. The AW109SP is a sophisticated, capable twin-engine helicopter, and its procedures establish a baseline of safety and predictability. Your job as a pilot is to apply them intelligently, adapting to the specific conditions of each flight. One of the most critical principles in this section concerns operating limitations. Every aircraft system, from engines to rotors to hydraulics, has defined minimum and maximum operating ranges. On the AW109SP, these limits are presented through instrument markings and cockpit placards. They define the envelope within which the aircraft was certified to operate safely. They are not suggestions. Here is the principle that every professional pilot must internalize. Every time a limitation is exceeded, every time a malfunction or emergency occurs, an appropriate entry must be made in the aircraft logbook. That entry must document which limit was exceeded, for how long, the extreme value that was reached, and any additional information relevant to determining what maintenance action is required. Why does this matter? Because the maintenance team working on your aircraft after your flight depends on accurate records. A missed logbook entry about an exceedance could mean a critical component doesn't receive the inspection it needs. That risk doesn't disappear, it gets passed on to the next crew. The AW109SP makes this documentation easier through the Integrated Display System, which pilots commonly refer to as the IDS. This system maintains automatic logs of limit exceedance data, fault codes, and caution and warning signals, all stored in non-volatile memory for later retrieval by maintenance personnel. Think of the IDS as the aircraft's own digital safety journal. It remembers what happened so the maintenance team can assess what needs attention. But the IDS is an aid, not a replacement. The logbook entry is your professional responsibility. A well-executed flight begins with a well-planned flight. The procedures are clear on this. Every flight must be planned adequately to ensure safe operations and to give you, the pilot, the data you will actually need during the mission itself. What does adequate planning look like in practice? Start with the mission itself. What type of operation are you conducting? Where are you going? These two questions determine which performance charts you will need. The AW109SP's Basic Rotorcraft Flight Manual, the RFM, contains performance data organized by flight regime. Different missions may also trigger different supplements. If your specific aircraft has optional equipment installed, a hoist, medical equipment, floats, the relevant RFM supplements must be reviewed before flight. Then comes weight and balance. This is never an afterthought. The AW109SP has defined center of gravity limits, both longitudinal and lateral. These limits define where the aircraft can be safely controlled in all flight regimes. Exceeding those limits doesn't just create handling difficulties, in extreme cases, it can make the aircraft uncontrollable. Your weight and balance calculation must account for the weight of fuel on board, including anticipated burn throughout the flight, oil and fluids, payload, passengers, cargo, crew equipment. You then compute your takeoff gross weight and your anticipated landing gross weight. Why both? Because fuel burn shifts your center of gravity during flight. An aircraft that starts within limits may drift out of them as fuel is consumed, or conversely, a heavy takeoff weight may limit your performance in ways that become critical at high altitude or in hot conditions. The AW109SP's maximum gross weight is 3,175 kilograms, for both ground taxiing and takeoff and landing. The minimum gross weight for flight is 2,050 kilograms. These are hard limits. Your planning must confirm you remain within them throughout the entire flight profile. Proper weight and balance planning is your first line of defense before you ever leave the ground. Pilots who skip it, or treat it as a formality, are accepting a risk they may not even know they are carrying. Now we arrive at the heart of this episode, the pre-flight inspection. There is a principle in aviation worth stating plainly: if you fail to look, you will fail to find. Aircraft systems can fail silently. A hydraulic line begins leaking overnight. A rotor tie-down is overlooked by a distracted line technician. A pitot tube cover remains in place after maintenance. None of these failures announce themselves. They wait for the moment you need the system they affect most. The pre-flight walk-around is your last opportunity to discover a problem before it becomes an emergency in the air. Before we begin, a critical warning. If any failure is detected during pre-flight checks, maintenance action is required before the aircraft can fly, unless that specific defect is explicitly covered by a minimum equipment list dispatch authorization. Professional helicopter operations do not accept the wheel assess it once we're airborne approach. If something is wrong on the ground, it stays on the ground until it is fixed. Now, the structure of the inspection. The AW109SP pre-flight is organized into 7 inspection areas. It begins at the nose of the aircraft and proceeds clockwise around the helicopter, a pattern shown in the Quick Reference Handbook. This clockwise discipline is deliberate. It creates a repeatable visual sequence that ensures nothing is skipped, regardless of time pressure or distraction. Throughout the entire walk-around, you are always looking for the same fundamental categories of problems: any leaks from drains, any obstructions in vents or air intakes, and any access panels or antennas that are not secure. Let's walk through each area now. You start at the front of the aircraft. Before you examine anything else, one check must be confirmed: the main rotor tie-downs and the tail rotor tie-down must be removed. This is non-negotiable. Attempting to start engines with tie-downs in place would be catastrophic. Confirm they are off the aircraft and stowed. At the nose itself, you are conducting a general structural assessment, looking for any damage, deformation, or anomalies that could suggest the aircraft was involved in a hard landing or ground contact event since its last inspection. The ventilation air intake at the nose must be free of obstruction. Birds nest in these openings. Debris accumulates. Always look. The pitot tubes are your primary source of airspeed and altitude data. Their covers must be removed. This is one of the most famous sources of air accidents in aviation history: crews departing with pitot covers installed. The tubes themselves must be clean, undamaged, and completely clear of any obstruction. The nose landing gear gets a thorough look. Shock strut extension, is it within normal range? Any evidence of hydraulic leaks? Tire condition, including any cuts or flat spots? And tire pressure. Now you open the nose compartment access door. Inside, the avionics components receive a visual check, looking for condition, secure mounting, and no signs of chafing wiring or loose connections. Also inside the nose compartment are the hydraulic accumulators. Here is a caution that pilots sometimes underestimate. You discharge the accumulators by pressing the relevant red push buttons. But discharging the accumulators temporarily removes your parking brake capability. Before you do this, the aircraft must be secured with wheel chocks. An unexpected helicopter rolling on a ramp is a very preventable, very serious incident. After closing and securing the nose compartment door, one final check at the nose, all drains and vents free of obstruction. Moving clockwise, you arrive at the right side of the aircraft, the pilot's side. This is the most extensive inspection area. Begin at cockpit level. The windshield, roof panels, lateral and lower transparent panels, all must be checked for condition and cleanliness. This matters more than it might seem. A contaminated or cracked windshield impairs your spatial awareness, particularly in instrument meteorological conditions or at night. The windshield wiper gets a condition check. The outside air temperature sensor on the right side must be clean and completely unobstructed. Your OAT reading feeds into multiple performance calculations, including density altitude determinations. Work along the fuselage exterior. The pilot's door window view condition, cleanliness, confirmed secure. The antennas on this side get a visual check. Antenna damage is easy to overlook, but a damaged antenna can mean loss of communication or navigation capability precisely when you need it most. If emergency floats are installed on this aircraft, their electrical connector requires a specific check, the cap must be confirmed locked, and the chain in good condition and secure. The sliding passenger door gets checked for window condition and cleanliness. The jettison windows, the ones your passengers would use in an emergency exit, deserve particularly careful attention. You are verifying the security of the windows themselves, the seal retainers, and, critically, the condition of the emergency exit markings. These markings must be clearly legible. In an actual emergency, a passenger may have seconds to read and follow those instructions under extreme psychological stress. Now open the fore and middle access doors on the right side. Inside, the servo hydraulic system valves and filter group require a check for leaks and filter status. A red button protruding from the filter housing signals a clogged filter. That is a maintenance finding, not a wheel monitor its situation. The hydraulic system tanks get a fluid level check, and both filler caps are confirmed secure. Using the service step, you move upward to access the main rotor head. This is one of the most critical portions of the entire inspection. The main rotor hub and blades require a thorough examination. You are looking at condition, any damage to the blade skin, any delamination, any signs of impact with an object, any fluid staining. Security, are all attachments secure? The rotor dampers, the lead lag dampers that control blade movement in the plane of rotation, are checked for condition and correct charge indication. The pitch change links and the swash plate assembly, along with the driving scissors, are all examined for condition and security. Any play, looseness, or damage in the pitch control chain translates directly into flight control problems. This is the mechanism through which every collective and cyclic input you make reaches the blades. Through the hydraulic servo's access door, you inspect the servo actuator, specifically the one identified by the yellow decal. You are looking for condition and any signs of hydraulic leaks. The main transmission and its visible accessories get the same treatment, any indication of oil leaks, which could signal seal failures or internal damage. On the right side, you also check the transmission external oil filter's bypass indicator. Again, a red button protruding means the filter is clogged. A clogged transmission oil filter is a maintenance finding that grounds the aircraft. Now the right engine. The engine air intake screen and intake chamber must be clear, covers removed, free of damage and any foreign object debris. FOD ingestion is one of the leading causes of engine power loss, and turbine engines are particularly vulnerable during ground operations. Open the engine access door for the engine compartment inspection. You are checking engine compartment drain filters for obstructions, the entire engine area for fuel and oil leaks, and the engine oil level via the sight gauge. The engine oil filter impending bypass indicator must show the correct indication. The red pop-up indicator must not be visible. The engine transmission drive shaft and engine supports are checked for condition. Now a particularly important item, the engine fire extinguisher indicator disc. This disc must be confirmed in the red position. If it is not in the red position, if it has shifted or is missing, it means the extinguisher bottle has already been discharged and requires replacement before flight. An aircraft with a discharged fire extinguisher bottle is an aircraft without fire suppression capability. No crew should accept that. The fuel filler cap is confirmed secure. The igniter access door opens for inspection of the igniter box condition, the engine fire extinguisher bottle condition, and the engine exhaust support. The engine exhaust must have its cover removed, and the exhaust must be free of fuel residue. Fuel pooling in an exhaust is a fire hazard on start. Completing the right fuselage area, the main landing gear on this side receives the same thorough treatment as the nose gear, shock strut extension, any signs of leaks, tire condition and pressure. The wheel brake disc is confirmed for freedom of movement. The landing gear locking system pin is confirmed for freedom of movement. Landing, taxi lights and their transparent covers, condition and cleanliness. Antennas, drain and vent lines, and the external power door are all confirmed. Rounding the aircraft to the right tail boom, the focus shifts to structural integrity and lighting. The tail boom exterior is inspected for condition, any cracks, wrinkles, or deformation that could indicate a tail strike or structural overload event. Even small wrinkles in the tail boom skin can be significant, as the tail boom carries significant loads in maneuvering flight. The lower anti-collision light gets a condition check. The horizontal stabilizer must be confirmed in good condition and secure. Position lights and floodlights, where installed, receive a visual inspection. At the tail of the aircraft, you are focused on the anti-torque system, the system that prevents the helicopter from spinning uncontrollably in flight. The tail fin and skid structure receive a condition check. The tail navigation light is inspected. Opening the tail rotor driveshaft door reveals the driveshaft bearing. This bearing runs continuously during all powered flight. You are checking condition, security, and any evidence of grease leaks. A failed tail rotor driveshaft bearing can lead to complete loss of anti-torque control, one of the most demanding emergencies a helicopter pilot can face. The tail rotor gearbox access door opens for the gearbox inspection. You are confirming no leaks. The tail rotor pitch control lever, the component that translates your pedal inputs into actual blade pitch changes, gets a condition check. The oil filler cap is confirmed secure. On the left side of the tail boom, you begin with the tail rotor gearbox oil level check. This check must always be performed before the first flight of the day. The tail rotor hub and blades receive the same level of thoroughness as the main rotor, condition, cleanliness, and freedom of flapping motion. The tail rotor pitch change mechanism, condition and security. Any binding or stiffness here affects your ability to control yaw. The tail rotor driveshaft covers open for inspection of the driveshaft bearings on the left side. Here you are specifically looking for any marks of slippage on the bearings, which would indicate that the bearing is no longer properly retained. The tail rotor shaft inspection pins are checked for freedom of movement. The left side of the fuselage mirrors much of what you inspected on the right, but with several important additional checks. Open the baggage compartment door. Inside, if cargo is on board, its security must be confirmed. Also accessible through an inspection door inside the baggage compartment is the tail rotor hydraulic servo actuator, checked for any oil leaks. All circuit breakers in the baggage compartment are confirmed in. The compartment door is then closed and secured. Drain and vent lines on the left side, free of obstruction. Emergency floats connector, if installed, cap locked, chain confirmed secure. The left main landing gear, shock strut, leaks, tire condition and pressure, brake disc freedom, locking pin freedom. The left engine inspection mirrors the right, intake screen clear, engine compartment drain filters free, engine area checked for fuel and oil leaks, oil level confirmed, oil filter bypass indicator confirmed clear. Drive shaft and engine support condition. Engine access door secured. Moving up via the service step, you access the transmission from the left side. Here is a critical caution worth emphasizing. The transmission oil level check must be performed before the first flight of the day. It can be considered valid for a maximum of 5 flights. After that, it must be rechecked. The oil level must fall between the minimum and maximum markings. The hydraulic servo's access door on the left side opens for inspection of the servo actuators, this time, the actuators bearing red and blue decals. Condition and leaks, same as the right side. Moving back down the left fuselage, cowlings and fairings confirmed secure. Sliding door jettison windows checked for seal retainer security and emergency marking condition. The sliding door checked. The fuselage exterior confirmed. Open the fore and middle access door on the left side for one of the most important checks on this side, the flight control rods. What you are confirming here is freedom of movement. Any restriction, binding, or damage in the flight control system is a critical finding, one that grounds the aircraft. The co-pilot's door and window, the left outside air temperature sensor, windshield, transparent panels, windshield wiper, and antennas complete the left side exterior inspection. With the exterior complete, you enter the aircraft. Cabin interior. In the passenger cabin, begin with the jettison windows, both right and left sides. Check the seal retainer condition and confirm the red emergency strap is in place. The sliding doors on both sides are operated through their full range to verify that locking and mechanical stop devices are functioning correctly. Passenger safety belts are confirmed in good condition. Any unoccupied seats must have their belts fastened. This is not just a regulatory requirement, it prevents belts from becoming entanglement hazards in an emergency. Check the cabin interior for overall equipment security and confirm the presence of all required markings. The first aid kit must be on board with its contents accounted for. Both sliding doors are closed and secured. Cockpit interior. Moving to the cockpit, you work through both sides systematically. Both co-pilot and pilot side, jettison handle confirmed in the correct position and secured. Safety belt and inertia reel in good condition. Seat secured. Flight controls, collective, cyclic, and pedals, confirmed in good condition and secure. Lower and lateral transparent panels clean and undamaged. Doors closed and secured, sliding windows closed. The cockpit fire extinguisher must be confirmed charged and secure. Any passive vibration absorber cover, if installed, is checked for security. All instruments, panels, and circuit breakers, main panel, pilot overhead, co-pilot overhead, are confirmed set correctly. All switches and controls that should be off are confirmed off, guarded, or in the normal shutdown position. Electrical power-up checks. Now comes the electrical portion of the pre-flight. A note worth emphasizing before you begin, these checks can draw significant electrical current. Monitor for battery charge depletion if you are running on battery alone. Use external power if available. This preserves battery charge for engine start. With battery power on and the generator bus switches confirmed on, connect external power if required. When external power is connected, the battery automatically disconnects. You will see a bad off caution message on the display. Confirm this message appears. If the battery requires charging, select the battery switch to the EPU position. Always confirm that your external power source is supplying not less than 28 volts. With electrical power confirmed, test all exterior lighting, anti-collision lights, position lights, taxi lights, and landing lights. All lighting must be confirmed functional before every flight. A burned-out landing light on a night EMS mission is not a problem you want to discover in the air. Fuel system checks. The final checks in this section address the fuel system, specifically the fuel filters and fuel pumps on both sides of the aircraft. The left airframe fuel filter is drained while the corresponding fuel pump is operating. You press the red button on the filter gently, carefully, because fuel is pressurized. You are checking for bypass indication and the corresponding caution message on the display. Then the left fuel pump itself is tested. The fuel drain switch is raised and set to the left tank drain position. You check for fuel dripping from the drain and confirm the corresponding caution message is displayed. The switch is then returned to off. You verify the dripping stops, and the caution message clears. The right fuel pump and right airframe fuel filter receive the same treatment. With these fuel system checks complete, external power is disconnected, the battery switch is placed off, and the generator bus switches will confirm off automatically. The pilot's door is closed and secured. The pre-flight inspection is complete. Let's bring this episode together. 3 things I want you to carry from this episode. First, the philosophy of standardization. Normal procedures are not there to limit your judgment. They are there to protect you from the natural variability of human attention. Even the most experienced pilots benefit from a structured sequence, because structure ensures that nothing is missed under pressure, fatigue, or distraction. Second, limit exceedances must always be logged. The aircraft's maintenance history depends on accurate, honest logbook entries. Every time you exceed a limitation, you have a professional duty to document it. The IDS helps, but the logbook is your responsibility. Third, the pre-flight walk-around is your last chance to discover a problem before it becomes an emergency. Walk it methodically, every time, without shortcuts. The clockwise sequence exists for a reason. The groupings, hydraulics, then rotor head, then engine, exist for a reason. Follow the pattern, and you will find what needs to be found. In Episode 2, we move inside the cockpit for the engine pre-start checks, where you prepare all aircraft systems before bringing those 2 Pratt & Whitney turboshafts online for the first time on each flight. Until then, fly smart, fly safe. Total estimated duration, 45 to 55 minutes at 135 WPM pacing, moderate, allow pauses after key points, pause. Markers indicate deliberate beats for listener absorption. No item numbers should be read aloud under any circumstances. Emphasize safety-critical items with slightly slower, more deliberate delivery.